we're going to be completing our review video for Chapter 10, Section 4. Chapter 10, Section 4, and as always, we start with our learning target. Our learning target today is to graph cubic equations. Notice that a cubic equation is when the power, or x, the power of x is 3. So I'm going to pick some values. I'm going to pick -2, -1, 0, 1, and 2 for my x. I'm going to calculate the corresponding values of y here so that I can graph them. So if I put -2 in here, -2 cubed would be -2 times -2, which would be 4, times -2 would be -8. -8 divided by 2 is -4, but I've got this negative out in front, so it would be a +4. Then I've got -1 cubed, which would be -1, -1/2, but it would become a +1/2 because of the negative out front. 0 to the third power is 0, 0 over 2 is 0, 1 cubed is 1, so it would be 1/2, and then it would be the negative out in front, so now it's a -1/2. And 2 cubed, 2 times 2 is 4, times 2 is 8, 8 over 2 would become 4, and 4 with the negative sign out front becomes -4. All right, so let's try to graph these here. Again, my ordered pairs are -2, 4, -1, 1/2, 0 and 0. That should be -1/2. Or is it? Let me see here. -1 cubed would be -1. -1, well, it would be +1/2. Sorry about that. It is +1/2. And 0, 0, and then 1, -1/2, and the last one is 2, -4. All right, well, let's graph these here. Then we're going to go -2, 1, 2, and +4, 1, 2, 3, 4. So that would be my first point. And then -1 and a +1/2 would be about right here. And then 0, 0. And now let me drop this down a little bit here. So I've got these 3 points so far. Then I've got 1 and -1/2 would be about right here. And then I've got 2 and -4, +2, -1, 2, 3, 4. All right, so the graph will look something like this. Okay. And that's kind of a standard look to cubed equations that are cubed. All right, graph of y is equal to 2 times x cubed, 2 times x cubed. As I look at this, they've all got the same general shape, but one of the things I notice is if I plug in 0, I'm going to get 0 here. So it's got to go through the origin, so it cannot be A, it cannot be B, so it's either going to be C or D. And if I try, let's see how steep it gets, how quickly it gets steep. Let's try -2. -2 cubed be -2 times -2, which would be 4. 4 times -2 would be -8. Times 2 would be a -16. So it'd be -2 comma a -16. So it gets steep very, very quickly. And I'm going to try a positive. It will also get steep very quickly, but going up. If I go -1, -2, it doesn't get there on this one. If I go -1, -2, it crosses much too soon. So C is the better approximation. It must be C. Write a function for the volume of V of the triangular prism below, graph the function, then estimate the dimensions of the prism that would give you a volume of approximately 40 centimeters. All right. Well, first of all, to find the area here, or the volume rather, volume would be the base area times the height. Well, the base area is a triangle, so it'd be 1/2 of x times x, or x squared, and the height would be 2x plus 8. So my equation here at this is that volume is going to be equal to 1/2 of x squared, that amount times 2x plus 8. So I'm going to multiply through here, and I see if I can divide everything by, this would be just x plus 4. And then I take x squared times x, I would get x cubed plus 4x squared is my equation. I'm going to plug in some values of x. I'm not even going to mess with the negative ones because I know I cannot have a negative dimensions here or here, so I cannot have a negative dimension. I'm going to plug in some values into that equation of, I'm going to start with 2 and then 3 and then 4 and then 5 and then 6, and we'll see what we get. These are the values of x. I'm going to calculate my values of y. So 2 in for x would be 2 cubed, which is 2 times 2 is 4 times 2 is 8. So it would be 8 plus 2 squared, which would be 4, times that would be 8 plus 16. 8 plus 16 is 24. If I plug in 3, 3 cubed is 27. 27 plus 3 would be 9 times 4. 9 times 4 is 36. 27 plus 36 would be 63. If I try 4, 4 cubed, 4 times 4 is 16, times 4 would be 64. So it would be 64 plus 4 squared would be 16 times 4, which would also be 64, and that'd be 128. So we go way off the charts here, 128. And if I look at the graph here of this, I'm going to go, this is 1, 2, 3, 4, and we can stop there. If I graph 1, I'm going to get an answer of 24. So let's go 5, 10, 15, 20, 25, 30, 35, and 40. All right. So if I go 1, well, we didn't figure out 1. 1 squared would be 1 plus 1 cubed would be 1 plus 4, which would be 5. So it'd be 1, 5. So let's go 1 and 5 would be right here. And then 2 and 24 would be about right here. And 3 and 63 would be off the top of the charts way up over here. 0, 0 would be like this. So this is a graph that looks very quickly up like that. Where about does it go across the 40 line? It crosses the 40 line somewhere at about 2.5. So the approximate value of x here would be 2.5 is equal to x. 2.5 is equal to x. If we actually plug that into our equation to calculate here, we would get 2.5 squared, cubed, 2.5 cubed plus 4 times 2.5 squared. And if we work that out, we get just a little bit over 40. All right, a rectangular prism has a square as the base and a height of x minus 4. Use the graph of this function to estimate the dimensions of the prism that would work. Well, if it's got a square as the base, okay, square is the base, that means it is x, and the height would then be the equation that they give, x minus 4. So as I calculate the area of the base, remember the volume is equal to the base area times the height. So the volume is equal to the area of this square, which would be x times x, or x squared, and the height would be x minus 4. So as I multiply here, I'm going to get x cubed minus 4x is equal to the volume. That's my equation. As I look at this here, if this is a value of x and this is a value of x, and then this has got to be x minus 4, it doesn't work, so it cannot be a. This could be x of 3, and then x minus 4. You know what? That doesn't work either. I could have 4 feet by 4 feet, so that would be x would be 4, x would be 4, and then 4 minus 4. You know what? That one doesn't work. The only one that's even possible is this one, where I say that the x is 6, the other x would be 6, and then 6 minus 4 would be 2. So this at least fits the pattern of our equation. Let's figure this out. 6 times 6 is 36, times 2 would be equal to 72. That's a very close approximation. So we think we're going to get a graph here at 72, or about 6. X is equal to 6, and I'm going to stop right there. That works just fine. We can quit at that point.